you are welcome to Tutor Think. Today I'll be taking you through differentiating a product function part 4. I actually have done 3 separate videos under this topic, taking different examples. You can go through my channel, open the playlist Engineering Maths 1, and you see these videos there. You can go over them to equip yourself with more examples. So in this one I have 2 separate functions, so I'll take my time to go through them for you to get the understanding. I also want you to subscribe to this channel if you have not, for more updates, and let's see what we have today. To make the work very simple, I will label all the functions to be equal to y. So let's say that let y be equal to e raised to the power 2x cos 3x. Then in mind, I would use 2 methods. Actually, I want to use both methods for you to get the understanding, and you decide on which one that you prefer. So for this one, let's use the variable method. I don't know how to put it, how to name it, so let's use the variable method. I'll represent this with the first a variable and this with another variable. So I'll say that let u be equal to e raised to the power 2x, and then let v be equal to cos 3x. So now your next step is to differentiate u with respect to x. So I have du dx will give me 2e raised to the power 2x. So to differentiate an exponential function, whatever value is here or whatever coefficient is here, use it to multiply the whole function and raise it to the same power. So if there is 1 here, it will be 1e2x. If there's 2 here, it will be the same thing. If negative 2, it will still be negative 2 times e raised to the power 2x. That's how you differentiate an exponential function. And then we differentiate this one. So dv dx will give you, for this one, if you have something like this, all you need to do is to differentiate the 3x, whatever you have here, first. When we differentiate 3x, the result is 3. Use it to multiply the differential of cos. Now when you differentiate cos, the result is minus sine. So let me use an example here. If I have cos, let's say 4x, then when I differentiate this, I'll first differentiate the 4x. 4x here means 4x raised to the power 1. So when I differentiate something like this, it will be 1 times 4. Use the power to multiply the whole function. X raised to the power 1 minus 1. So it will be 4x raised to the power 0. It's giving me 4. Anything to power 0 is 1. So that means we will get 4. So 4. Then you multiply the result by the derivative of cos something. Let's say cos x, or the derivative of cos will give you minus sine. So it will be minus sine. The same what? You have 4x there, so you repeat it, the same 4x. So now this result will give you minus 4 sine 4x. So now this is a shortcut method. Actually, you can use what we call the chain rule to differentiate this one by representing everything here with a certain variable, let's say u. That method is not really important here because this is not a question given to me to solve. It's actually part of a question I am doing, so there's no need for me to apply chain rule. So here, when I differentiate the cos, I am getting minus sine 3x. So let the negative come here, sine 3x. So this is it. Then I apply the product rule because it's a product function. So from product rule, I have dy dx because the main function is y with respect to this. That's what you said. So dy dx will be the first variable, u dv dx plus v du dx. So you take the derivative of the second function, you use it to multiply the first function. You take the second function, you use the derivative of the first function to multiply. So u dv, and remember that addition is commutative, so you can start with v. If you take v here, then you say that v times du dx plus u times dv dx. It will still give you the same answer. This is not quotient rule. Quotient rule, you can turn it. So now I have my dy dx giving us, what is u? U is this. U is what? E raised to the power 2x. And then multiply the result by dv dx. The dot here is multiplication. So dv dx was minus 3 sine 3x. Then you add it to, what is v? V is cos 3x. So multiply it by du ds, and du ds was 2e raised to the power 2x. So this is what we have. Now we can simplify the function, and I have my dy dx giving me minus 3 e raised to the power 2x sine 3x. You just multiply, plus I have 2 e raised to the power 2x cos 3x. So now I have a common factor here, this and this. I can just factorize it out. So I have my dy ds giving me e raised to the power 2x. I want to write the positive one first, since this is negative. Then into brackets, I'll be left with 2 cos 3x. So 2 cos 3x minus this one, 3 sine 3x. I decided to write the positive one first since this is negative. You can choose to write the negative one first. It's still correct. And this is your final answer. So this means that when you use this to multiply this, you get this function, and when you use this to multiply this, you get this function. There's addition here, that one is not important. So this is the end of the solution. I will use the other method to differentiate the same function again. You choose the one that you want. All I need to do is that I will say that dy dx equals, you hold the first function or maintain the first function, e raised to the power 2x, multiply the result by the derivative of the next function. That means take derivative of the next function, cos 3x dx. This means d into bracket cos 3x dx. I'm differentiating cos 3x with respect to what? X. Then plus, now pick and maintain the second function, which is cos 3x, multiply by the derivative of the first function, d of e raised to the power 2x dx. You can decide to start with this one and then pick this one, or any of them is correct, because multiplication is commutative, addition is commutative. So I have my dy dx giving me e raised to the power 2x times, when I differentiate this one, the result is, differentiate this side, we have minus 3 sine 3x, then plus cos 3x multiplying differential of this will give me 2 e raised to the power 2x. So now we can now simplify. Dy dx is giving us minus 3 e raised to the power 2x sine 3x plus 2 e raised to the power 2x cos 3x. So now it's very simple for us. We just factorize the one that is common out. You can also leave your answer here. So I have my dy dx giving me e raised to the power 2x into bracket. Let me write the positive one first. 2 cos 3x minus 3 sine 3x. And this is your final answer. So this is it. You decide to choose the method that you want. This is actually 1, 2, 3, 4 lines. As when we compare it with the first one, it's still the same, but the first one is a little bit longer. But I prefer this method is because it's very simple. You just need to know how to quote the formula, and the formula is what we use to do this one. So for you to apply this method, you need to have this, the product rule formula, in your mind, because u stands for the first function, dv/ds stands for derivative of cos 3x, and blah blah blah. So now let's take the next example. Let's use the first method. Represent this with u, represent this with v. So we say that let u be equal to x squared and then v be equal to sine 3x. So now you differentiate the u with respect to x. So the u dx will give us 2x, and then the v ds, you just need to differentiate this one, we get 3, and then you differentiate sine. Remember, when you differentiate sine, you get cos. So I'll have cos the same 3x. So now I'll apply product rule, and the product rule says dy dx will give you u dv dx plus v du dx. So now dy dx will give us, now we substitute, what is u? U is x squared, multiply it by what is dv dx? It is 3 cos 3x. So multiplying 3 cos 3x plus what is v? Sine 3x. Multiplying what is du dx, which is 2x. So now I have my dy dx giving me 3x squared cos 3x plus 2x sine 3x. So now this can be your final answer. You can leave it here, but I can also decide to factorize something out. I have x here, which is x squared, and I have x here. So I can pick one x and factorize it out since there's only one x here. So my final answer, you can leave it here if you want, but if you want to simplify it further, you have dy dx will give you x outside 3x cos 3x. Remember, you can't touch this one. You can't factorize this thing out. This x, you can't take it out. If you are not familiar with trig functions, you can. I just wanted to let you to know that you can't take this one out, because assuming this value or this x is a certain value, let's say 5, when I multiply by this, I'm getting cos 15. It becomes an angle, and there's cos 15 degrees. There's no way I can bring it out, so I'm just using that to explain. So you can't touch this one. So plus 2 sine 3x. I can only touch the one that is here in front of it, but if I'm differentiating, I can work on it. So this is your final answer. So that this time this will give you 3x squared, this time this will give you 2x. So this is your final answer. Now I will not use the other method to do this. I want to challenge you. If you are watching this video, I want you to use the other method in the first example to arrive at the same answer. Once you are able to do it, that means you have really gotten the concept. Thank you very much for joining me here on Twitter Think. My name is Daniel, and then I will see you in my next video. But wait, if you haven't subscribed, please do.